Hello everyone, so in this video we'll be talking about the sigmoid function in PyTorch, that is torch.nn.Sigmoid. So let's start with the documentation. So this is going to be a very simple and easy video because as you can see torch.nn.Sigmoid, it doesn't really have any parameters. I mean there are arguments and keyword arguments, but we won't be passing them. So it does not have any inherent parameters that we have to tune. As you can see in the example or in the equation over here, sigmoid of x, basically function which is represented like this, the row of x equal to 1 by 1 plus exponent of minus x. Okay, now this x can be a number or it can be a vector. We will see using a vector in our example program. Okay, again same thing like all the other activation functions, the input can be any shape and the output is going to be of that same shape. Okay, so sigmoid function, you can see over here it has been drawn, the graph has been drawn. At 0, this point is 0.5 the height, and here this axis is 0. As you can see, this is y equal to 0 and here it's y equal to 1. So let me draw the graph for you again. So so this is, let's say, the y-axis, this is the x-axis. Okay, so this is, as I said, y-axis and x-axis. Let's say this is equal to 1. Okay, 1, and so this is 0.5. okay, so the function basically comes over here very close to this line, this x-axis. Okay, very close, and then it kind of bumps up a little bit, and then again it plateaus here. Okay, it goes over here, so it will never touch uh, x y equal to 1, and also it will never touch y equal to 0. So it's going to be between, so the range is going to be 0 and 1, both of them will not be included. Okay, so this is going to be the range. Fine. Now this function is valid for any x, so I can write the equation again. So 1 by 1 plus exponent of minus x. So this function, this particular function, this is rho of x or sigmoid of x, is valid for rho of x, sigmoid of x is valid for any your value of x. Okay, so let's put x equal to 0. This will come out to be 1 by 1 plus exponent of 0 is 1, that is going to be 1 by 2 or 0.5. So as you can see over here, I said this is 0.5, this particular point over here. Okay, so there's nothing too complicated over here, so let's directly get to the code. Now obviously there is theory regarding why we choose sigmoid. It is used for binary classification and all that. In the last layer we use it when we have single neuron and we want to do binary classification. So I'm not getting into the theory of it because I expect you already know, otherwise there is this function already discussed in my channel. So let's start with the coding part. Okay, so very simple coding. Again, we have the simple imports of torch and torch.nn and nn. Then what you can do is you can have a random function over here which you can hit shift and enter. So torch.random rand n is going to generate this many, that is 10 number of random values, and it is going to store that vector in rand. Okay, so now let's go and print this particular vector. So you can see over here, this is the vector, there are 10 values. Okay, so let's apply this function, this rand function, this sigmoid function on this particular vector or tensor, whatever it is. Okay, so as you can see, all the values are, now one thing you can see is that when whatever value you give, this particular function, as I said, it gives you from 0 to 1. Okay, but for negative values, this is going to give any value from 0 to 0.5 for x that is less than 0, 0.5 for x equal to 0, and greater than 0.5 for x greater than 0. Okay, so greater than 0.5 but less than 1, 5 but less than 1. Okay, so 0 to 0.5, 0 is not included again. Okay, it's going to give a value of between 0 to 0.5 for all the x's that are lesser than 0. At x equal to 0, it's going to give 0.5, and x greater than 0, it's going to give something greater than 0.5. so that is there. So you can see over here, since this is a negative number, you get a positive value that is less than 0.5, but this is a positive number, as you can see over here, so you get a value that is greater than 0.5, and so on and so forth for all the values over here. Now what if you want to you want a custom implementation? Definitely very easy. So you define a custom function. So let's say cust underscore sig, and L is going to be your vector. Okay, it can be anything, so you can put over here X also, it doesn't matter. And I'm going to return, but I'm going to return the formula 1 by 1 plus exponent of minus X or minus L in this case. So you hit shift and enter, and finally you pass this rand, which is not changed. Okay, so you can see these two vectors are the same. You can see 0.1649, again you can see 0.1649, second value is 0.5831, here also you can see 0.5831. so basically what I'm trying to say is all the values of these two vectors are the same, because this function nn.Sigmoid is nothing but this function, that is the formula implementation of whatever we just saw. So I hope you like the video, and if you did really like the video, please like and subscribe.